All right, so the first question here is to graph the following. F of x is equal to x cubed minus 6x squared plus 9x. I think it's a plus 9x. Yeah, plus 9x. All right, so we have a polynomial here. When you're talking about polynomials, I believe some of the questions on the midterm do ask you to find the end behavior as well. So let's talk about the end behavior. So for the end behavior, we see that the degree of this polynomial is 3, which is odd, meaning one way is going to be going up, one way is going to be going down. And the leading coefficient is positive. So together, that means that it is going down on the left and up on the right. And so let's see. So let's find the rest of the stuff. We have Y-intercept. Set x equal to 0. You're going to get y equal to 0 minus 0 plus 0 is 0. This pen seems like it's not long for this world. And then the X-intercepts, you're going to set the whole function equal to 0. X cubed minus 6x squared plus 9x equal to 0. And this is definitely when you're going to want to factor if you can. So I'm going to factor on x. I'm left with x squared minus 6x plus 9. And then I'm going to factor this. This does factor as x minus 3 times x minus 3. So be careful. If you write this as x minus 3 times x minus 3, that's fine. But we do need to look at what intercepts we're going to get. So the intercepts are going to be x equal to 0. And that came from this factor that has a power of 1. So I'm going to get that has a multiplicity of 1, which means we're going to cross. And then from this factor, I get x equal to 3. Now, we have to be careful here because x equal to 3 really has a multiplicity of 2. Because I should be able to write this as x minus 3 squared instead of x minus 3 times x minus 3. So x equal to 3 has a multiplicity of 2, which means we're going to bounce. For a polynomial, that's it. End behavior, y-intercept, x-intercept. I should point out, if it's a second degree polynomial specifically, you'll also want to find the vertex because it's a parabola. But for a higher degree polynomial, we don't. We just say, okay, we've got all this stuff. So I've got a y-intercept of 0, an x-intercept of 3 and 0, and I'm going to be down on the left and up on the right. So I'm going to be down, and then I'm going to hit that point, and I'm going to go through. Whoops, I didn't plan very well there. Try again. And then I'm going to turn around and hit that point there. And I'm going to bounce off. And polynomial graphs should be smooth, right? There shouldn't be any like pointy parts or jagged edges. Definitely I've definitely seen people in the past graph this more like this. Where they're kind of like, okay, right? Like, try to make it look smooth because it should be smooth. Yeah. All right, that's that. That's all there is to that one. Oh, it's not all there is to that one. What's the domain here? So when we ask for the domain of this function, we really are asking, are there any roots, division by 0, or null logarithms? No, there's none of those things. And that's always going to be the case for a polynomial. The polynomials always have domain everything. So the domain here is all real numbers, which you can write it that way, or you can write it as negative infinity to infinity. The range here, well, if we look at the graph starts at negative, it goes down as low as negative infinity, and we get all the y values from negative infinity to infinity. Right? There's nothing missing. So the range is also everything. Questions about this one? All right. So go to the next one, which is f of x equal to 8 to the x plus 1 minus 4. So this is an exponential graph, right? It's going up from left to right. And I see that we have a shift to the left by 1 and a shift down 4. I know that usually an exponential function would have a horizontal asymptote at y equal to 0. But the shift down is going to shift my horizontal asymptote, right? The horizontal asymptote was y equal to 0, but now if we subtract 4, now it's going to be 0 minus 4, which is negative 4. So that's our horizontal asymptote, negative 4. Really, your horizontal asymptote is just going to be however much you shift up or down. Yeah, let's start. Sometimes I like to start graphing the stuff before I actually find all the things. There's my horizontal asymptote. I do, well, in fact, so if I graph this thing, right, it's going to go up like this, and I can see that I'm definitely going to have an X-intercept and a Y-intercept. So I should work on finding those. I mean, I guess you could also point out that, yeah, we know that we would usually start at the point 0, 1, and that's going to go over 1 and down 4. So we're going to get the point, you know, negative 1, negative 3. I don't think we need to actually plot that point or think about that point, but it is there. So let's have the Y-intercept. The Y-intercept, so let's see if I set x equal to 0, I'm going to get y equal to 8 to the 0 plus 1 minus 4. 8 to the first is 8. 8 minus 4 is 4. So my y-intercept is positive 4. So it's going to get, so that's why I probably wouldn't actually bother trying to plot this point, because, right, it's going to be hard for me to make the graph look reasonable and go through this point and then up super steep like that. So I'm probably going to kind of ignore this point and make my graph look not exactly perfect. That's okay. So now I'm going to do something like this. And your exponential functions especially don't have to look perfect. I mean, none of them have to look perfect, but the exponential ones can look especially not perfect. Now, the other thing I should find is there is an X-intercept right there. So to find the X-intercept, I'm going to erase some of this over here. We're going to set y equal to 0. So I'm going to set the function equal to 0. So 0 equals 8 to the x plus 1 minus 4. I like to keep things positive, so I'm going to add 4 to both sides. Say 4 equals 8 to the x plus 1. You could bring this over and say negative 8 to the x plus 1 equals negative 4, and then multiply both sides by negative 1, say 8 to the x plus 1 equals 4, or you just do this. And then I see that 4 and 8 are both powers of 2. So I'm going to write 4 as 2 squared, and I'm going to write 8 to the x plus 1 as 2 to the third to the x plus 1. And then I've got 2 squared equals 2 to the 3 times x plus 1. And now that the bases are the same, I can say that the exponents have to be the same. So that 2 is equal to 3 times x plus 1. Distribute the 3. 2 equals 3x plus 3. Subtract 3. 2 minus 3 is negative 1. Equals 3x. And divide by 3 to get x equal to negative 1/3. So this point right here is negative 1/3 comma 0. And again, you can tell, right, my graph is really not to scale. That's okay. All right. Last thing we need to do is write the domain and the range. So domain. This function, 8 to the x plus 1 minus 4, is not, it should, so it actually should be negative. So if I'm trying to solve, right, because I'm trying to solve, first of all, it looks like it should be negative, right? Because my x value definitely is on the left side, right, which is the negative side for x values. But the other reason I can see it's negative is that, right, if I'm solving this equation, 2 equals 3 times x plus 1, 2 equals 3x plus 3, and then I subtract 3 from both sides, and 2 minus 3 is negative 1. So the negative 1 equals 3x, and then I divide by 3, and negative 1 divided by 3 is negative 1/3. Hopefully that clarifies things. Cool. Oh, I was talking about domain. So for the domain here, no, it's all right. It's good to ask the questions. This is the time to ask your questions. If you've got questions, it's really good to ask them. If you're not sure why something is true, you need to know why it's true. The other thing I want to say here is that, oh yeah, so for domain, this function doesn't have a fraction, doesn't have a square root, doesn't have a logarithm. So it doesn't have any of the three things that impede the domain, so the domain is, again, everything. The range, on the other hand, is limited, right? The y values don't go all the way down to negative infinity. The lowest y value is almost 4. Sorry, negative 4. So the range goes almost all the way down to negative 4. So here's what I don't want to see for the range. The range is not negative 3 to infinity. The range goes lower than negative 3. This goes negative 3.5, negative 3.9, negative 3.9999999. Right? This goes almost all the way down to 4. So we say, sorry, negative 4. So we say it's going to be parentheses negative 4 to infinity, right? We get all the values down to, but not including negative 4, and then up to infinity. Other questions about this one? Is using 2 and the exponential solve for x, or can you find? You could solve for using another method. It depends on kind of what you're comfortable with. Usually, if I'm writing a problem like this, where you're going to have an x-intercept because you shifted an exponential function down, usually the bases are going to have a base in common so that you can do it that way. But if I want to solve, what was it? 8 to the x plus 1 equal to 4. Right? Another way you could do it is you could rewrite it as a logarithm. You could say, oh, this is the same as log base 8 of 4 equals x plus 1. But then you have to know that log base 8 of 4 is 2/3. Because again, right, this really says 8 to what power equals 4? Oh, it's 8 to the 2/3 power. And yeah, that kind of, right. So again, it's kind of the same work, just written a different way. But you could, if you wanted to, you could say, oh, log base 8 of 4 is log base 8 of 2 squared, which is 2 times log base 8 of 2. And then it might be easier to see that log base 8 of 2 is 1/3, because 8 to the 1/3 power is equal to 2. So then this equals 2/3, and then we subtract 1, and 2/3 minus 1 is negative 1/3. Another option, if you really wanted it, would be to take the log base 2 of both sides. You take the log, so use the base that's in common. The base that's in common for 8 and 4 is the base of 2. And you say, oh, log base 2 of 4 equals log base 2 of 8 to the x plus 1. Log base 2 of 4 is 2, because 2 squared is 4. And here I can bring down the power. It's x plus 1 times log base 2 of 8. The log base 2 of 8 is 3. And now we're back to where we were before, where we said, oh yeah, 3 times x plus 1 equals 2. 3 times x plus 1 equals 2. So yes, Alejandro, there are many ways you can solve this. You should do whatever you're most comfortable with. Yeah, good questions. Welcome, of course. So a reminder, an exponential function like this, where you have some constant base raised to a power with x in it, an exponential function will always have a horizontal asymptote and will never have a vertical asymptote. Let's look at the next one. Let's look at C. F of x equals to x over x squared minus 16. So for a rational function like this, in addition to doing the usual things for polynomials, we'll have to think about asymptotes. Well, let's do the usual things. So the y-intercept, we're going to set x equal to 0. We're going to get y equal to 0. X-intercept. For x-intercept, you really can set the whole fraction equal to 0, but also you can just set the top equal to 0. So you can set x over x squared minus 16 equal to 0. But really, that's just going to be setting x equal to 0. And then for vertical asymptotes, we're going to set the denominator equal to 0. So x squared minus 16 equals 0. I personally prefer to factor so I don't miss anything. This factors as x minus 4 times x plus 4. So I get x equal to 4 and x equal to negative 4. And finally, do I have a horizontal asymptote? Well, the degree on top is less than the degree on the bottom, right? It's a degree 1 on top, it's a degree 2 on the bottom. And when the degree on top is less, that means we have a horizontal asymptote and it's 0. So the horizontal asymptote here is y equal to 0. All right, let's graph it. I might need an additional point here. So because I only have really one point, I have the point 0, 0, right? The x-intercept and the y-intercept are the same for the origin. And I've got vertical asymptotes and 4 and negative 4. Okay, and then I don't know if I go up or if I go down. So I'm going to pick one more point. I'm not actually going to plug it in and find it. I'm just going to ask myself what happens. So I plug in x equal to 1. The top is 1, and what's the bottom going to be? It's going to be negative. I don't really care if it's negative whatever. It's negative. It's negative 15. But I just care that I have a positive over a negative, which is negative. So I know when I plug in 1, the y value is negative. And then, since I don't have any other x-intercepts, it can't cross the x-axis, so I have to go like that. And then you can either say that the vertical asymptote came from a factor with an odd power, so we switch and now we're up here. Or you can pick another number. You can pick something like 5. Say, oh, if I plug in 5, the top is positive, the bottom is also positive, and a positive divided by a positive is also positive. So we know that at 5 it's going to be some positive number, so I had to do that kind of thing. On the left side, it's going to be the opposite. Actually, you could use the fact that this function is odd to graph the left side, say it's going to kind of switch. Or you could do the same sort of thing. So if I plug in negative 1, the top is negative and the bottom is negative, and the negative divided by negative is positive. So it's going to be something like that. And then it's going to go up this way. And then down here, you can plug in negative 5. Plug in negative 5, the top is negative, the bottom is positive, and so it's a negative number overall. So just this. So there's our graph. What's the domain? Well, what's not in the domain? The vertical asymptote is definitely not in the domain. So the domain here is everything except for negative 4 and 4. So the way we write that is everything from negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. Where everything's in parentheses because we don't include infinities and we don't include 4 or negative 4. How about the range on this one? Well, let's see. It looks like I might be missing something, but I'm not, right? So if we look at this middle part, the range goes as low as negative infinity, and I don't miss any y values up to infinity, right? Even 0, even though horizontal asymptote is y equals 0, I still get y equals 0 as one of my values for the function. So the range here is everything. Okay. Questions about this one? All right, so the next one.
I have a question on how you graphed the last one.
Okay. One second.
When you plug in one point on those sides, like on the upper right and on the bottom left, how do you know which direction they're going?
Well, so I plugged in 5, and I got a positive number, right? I plugged in 5, you get 5 over 25 minus 16 is 9. You get 5 over 9. So it's like about 1/2. But I really don't care. I'm just kind of plotting a point. So I got that point right there, right? Now, the thing is, I have to have everything I have to have every x value in the domain except for what within the domain. So the x values get bigger. As I go this way, what does the function have to do? Well, we have a horizontal asymptote. So as we go further out in either direction, your function has to get closer and closer to the horizontal asymptote. As I go this way, back towards this vertical asymptote, well, there's only one option when I go, well, there's 2 options. I can either go up to infinity or down to negative infinity. But I can't go down to negative infinity because I don't have an x-intercept. So I have to go up this way. And really, one second. Really, what I'm using the fact is that I know with a vertical asymptote, I'm either going up to infinity or down to minus infinity. And since I was above the x-axis, I had to be fully above the x-axis, meaning I had to go up to infinity. I couldn't be going down to negative infinity. Go ahead.
Oh, I said I got it.
Okay, sure. Right. So, I mean, you could say because of the vertical asymptotes, Alejandro, you could also just say because you can't plug in those numbers, right? If you plug in 4, you get division by 0, which means that number is not the domain. So, yes, we don't have -4 and we don't have 4 because they're not in the domain of the function. And yes, that corresponds to, in this example, having a vertical asymptote. A lot of the time, having a number that's not in the domain means it's going to correspond to a vertical asymptote, but not always necessarily. But usually in this class. Let's look at the next one, which is f of x equal to the square root of 2x minus 4 plus 3. So this one definitely has a shift to the right and a shift up. So it's going to go up 3. And now here the thing is the shift to the right is actually tricky. It's not going to shift to the right by 4. It's going to shift to the right by 2. Because really this is the square root of 2 times x minus 2 plus 3. And that might be kind of hard to see. So what I would actually really recommend here is before you do anything else, actually, let's talk about the domain before we do anything else. So for the domain here, I'm going to set the insides of the square root to be greater than or equal to 0. Right? For a square root, that always has to be true. So then, if I solve for x, 2x is greater than or equal to 4, x is greater than or equal to 2. So we're starting at 2, not at 4. Also, I should point out, this means we don't have a y-intercept, because x can't be 0. So y-intercept is none. X-intercept. X-intercept we probably also don't have one. In fact, we can see this, if we think about it, the fact that we're taking a square root function, which looks like this, and shifting it to the right and up, means there isn't going to be an x-intercept either. You could try solving this equal to 0, right? If you set this equal to 0, and then if you subtract 3 from both sides, you get the square root of 2x minus 4 equal to -3. Here we can see, oh, there's no solution, right? A square root is never negative. So we don't have any x-intercepts either. Really, this is all about just the shifting, right? This is going to shift 2 to the right and 3 up. And I suppose we could also mention that there is a horizontal compression by a factor of 2. But then I'm really just going to graph it. So it's like, it looks like this, and then it's like that. Domain. Well, we already know the domain, right? Literally, we found it. The domain is everything bigger than or equal to 2. starting at 2 inclusive to infinity. That point there is 2, 3. So for the range, how low do we go?
Three.
As low as 3. And then we get all the y values above that. So we go from 3 to infinity. That's it. Okay, let's look at the next one. So let's look at E, which is 1 over x minus 3. One over x minus 3, we definitely have a domain issue. But let's kind of just work through it. So y-intercept, set x equal to 0. We get y equal to 1 over 0 minus 3, which is negative 1/3. X-intercept, set the whole thing equal to 0, which has no solution, right? This fraction is never equal to 0. You could also multiply both sides by the denominator. If you do that, you get 1 equal to 0 times x minus 3. 1 equals 0. No, that's not true. There's no solution here. So there's no x-intercept. Let me ask you guys, do we have a vertical asymptote?
Yeah.
Yes, for sure. The vertical asymptote when the denominator is equal to 0, so when x is equal to 3. And then we do have a horizontal asymptote because, again, the degree on the bottom is bigger than the degree on the top. The degree on the bottom is 1. The degree on the top is 0 because there aren't any x's. So yes, y equals 0 is my horizontal asymptote. So let's see, I've got an x-intercept, a y-intercept of negative 1/3 and a vertical asymptote of 3. And I will remind you guys, I don't have any x-intercepts. That means I can't cross the x-axis. So since this point is already below the x-axis, all the other points, at least on this side of the asymptote, have to be below the x-axis. So I'm going to go this way, down like that. Right, that's the only choice we can make. We can't go up to infinity because that would involve crossing the x-axis, and we don't have any x-intercepts. And then to the left, as you go way out to the left or way out to the right, you have to get closer and closer to your horizontal asymptote. Now, what's going to happen on the other side of this vertical asymptote? Are we going to be going up to infinity or down to minus infinity? Well, you could either say the asymptote came from an odd factor, a factor with an odd multiplicity, right? Because it's really 1 over x minus 3 to the first. And if it's odd, it means you do the opposite thing. So one side goes down, the other side goes up. Or if it's easier, you can just pick a point. Pick a point bigger than 3, like 4. If you plug in 4, you get 1 over 1, which is positive. And since it's positive here, it's positive everywhere on this side. So it's got to do that. It's got to go up to infinity at the vertical asymptote, and then as you go further out to the right, it's got to get closer and closer to the horizontal asymptote. Okay, let's look at the next one. Oh, sorry, I forgot about the domain and range here. This one, the domain is clearly everything except for 3. So it's negative infinity to 3, union 3 to infinity. For the range, you get all the y values except for 0. So the range is negative infinity to 0, exclusive, union 0 to infinity. All right, let's look at the next one. F of x equals 2x minus 3 over x. And so, y-intercept. Set x equals to 0. Oh, x can't be 0, because that would be division by 0. So there's no y-intercept. X-Intercept. Set the whole thing equal to 0. So again, really when you're setting a rational function equal to 0, you're just setting the top equal to 0. So then you're going to get 2x equal to 3. You're going to get x equal to 3/2. Vertical asymptote, it's going to be where the denominator is 0, which is just x equal to 0. And the horizontal asymptote, now in this one, since the degree on top is 1 and the degree on the bottom is 1, so the degrees are the same, the horizontal asymptote is going to be the fraction of the leading coefficient. So it's going to be 2 over 1, which is just 2. Okay, that's everything. Let's graph it. So let's see, I've got an x-intercept at 3/2. It's right between 1 and 2. I've got a vertical asymptote at 0, which I'm not going to draw because it's just the y-axis. And I've got a horizontal asymptote at 2. Okay, so let's see here. I might need another point. Let's plug in 1 and see what we get. If I plug in 1, sorry, I have a vertical asymptote. I forgot my vertical. So if I plug in 1, when x is 1, I get 2 minus 3, which is negative 1. In fact, I can just plug in f of 1 is going to be negative 1 over 1, which is negative 1. So I have a point right here. And then for my vertical asymptote, I can see I'm going to have to go down to negative infinity. And then to the right, I'm going to cross, and you can either see that by seeing it comes from an odd factor, or by plugging in 2. If I plug in 2, I get 4 minus 3, which is 1 on top and 2 on the bottom. It's positive. And then we just get closer and closer and closer to our horizontal asymptote. On the other side of the vertical asymptote, when x is negative, it's going to be up here. And you can see that because this x is to an odd power, or by picking a point. If you plug in negative 1, negative 2 minus 3 is negative 5, divided by negative 1 is positive 5. So it's positive over on this side. It looks like that. The domain is everything except for 0. So it's negative infinity to 0, union 0 to infinity. And what appears to be the only thing missing from the range? What's the only number we don't get in the range? Yeah, exactly. Number 2. Right, in this case, and this is, so this is a little less precise than maybe you would want in future classes, but in this particular graph, there's no reason to cross the horizontal asymptote, and so we don't. And that's usually true, although it's not always 100% true, but it is true for this graph. Right? There is no reason to cross the horizontal asymptote, and the graph doesn't cross its horizontal asymptote. But you do get everything except for 2. So the range would be negative infinity to 2, union 2 to infinity. All right, let's look at the next one. Let's see, I've got, this one should be fairly straightforward. I've got f of x equal to 2 times the absolute value of x minus 1. So I know it's going to be absolute value function shifted 1 to the right and kind of vertically stretched by a factor of 2. We don't have to write that down, but it is good to know it. Let's find the usual things. Y-intercept. So x equals 0. Y is going to be f of 0, which is 2 times the absolute value of 0 minus 1. 0 minus 1 is negative 1. Absolute value of negative 1 is positive 1. 2 times 1 is 2. X-intercept. Set this equal to 0. For an absolute value to equal 0, the insides have to be 0. So earlier you're setting x minus 1 equal to 0, getting x equal to 1. There are no asymptotes when it comes to absolute values. This is kind of it. We know it's a V shape. We know we've got these points. And we do know that that point there at 1, 0 is the bottom of the V, because that's the smallest value the function can be, right? The smallest this can be is 0. This can't ever be negative because an absolute value is always positive or 0. It's going to look like this. You're certainly welcome to plot more points if you want to, but you do not need to. The domain here, there's none of the three things we have to worry about for domain. There's no division, there's no square roots, there's no logarithms. So the domain is just everything. The range here, on the other hand, we can see that the y values go as low as 0, but no lower. So the range is everything from 0 to infinity. For the x-intercept, yeah, I wouldn't say ignore, but you can say that. What I would actually really say is I'm dividing both sides by 2. So I divide both sides by 2. This divided by 2 is the absolute value of x minus 1, and 0 divided by 2 is just 0. And then for an absolute value to equal 0, the insides have to be 0. So then I'm getting that. So that's what's really happening there, is I'm dividing both sides by 2. But it's kind of like when we're finding x-intercepts for other things. Like if I was finding an intercept for 4 times x minus 3 to the 4th equal to 0, I kind of just ignore the 4 because really I'm just dividing both sides by 4. Yeah, it's a good question. It's a pertinent question. All right, let's look at the next one. We should be able to get through. Yeah. I might need an extra few minutes at the end. You're always welcome to leave if you have to leave. But I'm going to finish up the rest of these 3 graphing problems. And I will certainly post the video. If you don't have a chance to stay because you have to go somewhere, I get it. But if you can stick around, you should. So let's look at this one. What is it here? F of x is x to the 4th times x minus 2 times x minus 5. It's a polynomial. So we only have to worry about end behavior and intercepts. Right? There's no asymptotes at all when it's a polynomial. So end behavior, what's the degree of this polynomial? What's the highest power of x if you were to multiply it out? Yeah, 6. Right, because you have an x to the 4th times an x times an x. The leading coefficient, again, if you multiply it out, that first term would be positive x to the 6th. So it's going to be positive, and that's going to mean it's up on the left and up on the right. The y-intercept, if you set x equal to 0, f of 0 is going to be 0 times, it doesn't matter because 0 times anything is 0. X-intercepts, this is where we need to be a little more careful. So the x-intercepts we're going to get by setting each part equal to 0. So we're going to get, this one's going to give us x equal to 0. This one's going to give us x minus 2 equal to 0, which is x equal to 2. This one's going to give us x equal to 5. The multiplicity of this first one is 4. The multiplicity of this one is 1. And the multiplicity of this one is 1. So we know that at 0 we're going to bounce, and at 2 and at 5 we're going to cross. Okay, we know that we're up on the left and we're up at the very right. So we're up to the left of our leftmost point, and then we're going to do some stuff in the middle, and then we're going to be up again after the rightmost endpoint, intercept. So we're going to come down, we're going to bounce at 0. Whoops, we're going to try and make it look decent. And then we have to turn around so we can hit this intercept and cross at 2. And then we have to turn around so we can get to that intercept and cross at 5. And this one, I would not ask you what the range was, because there's no way we are able to tell what the lowest possible y value is there. The domain, on the other hand, I could totally ask you. The domain is everything. But yeah, the range here is not knowable with the current tools we have. In calculus, you will learn how to find what the lowest value is for this graph. And okay, yeah. Now I'm going to go back and look at the test and make sure I didn't ask you a range of a question like that accidentally. I don't think I did, but it's good to double check. Okay, let's look at the last two questions here, which we should be able to get done without too much extra time. So f of x equals log base 2 of x plus 2 plus 1. And for functions with logarithms or roots, I really think it's a good idea to start off by thinking about the domain, actually. So let's start with the domain. So here the domain is going to be, well, I know that the insides of the logarithm have to be greater than 0. So x has to be greater than -2. And in fact, that also tells us where our vertical asymptote is. The vertical asymptote for a logarithmic function is where the insides of the logarithm are equal to 0. So the vertical asymptote occurs when x plus 2 equals 0, which is x equals -2. You also could have seen this because you know how the transformation of this graph works. We know that the logarithm usually has a vertical asymptote at the y-axis, right? X equals 0. But now we're shifting the graph 2 to the left, so the vertical asymptote gets shifted 2 to the left. Okay, great. We also know that for a logarithmic function, there is no horizontal asymptote. Okay, let's talk about the Y-intercept. For the Y-intercept, you're going to set x equal to 0. And we're going to get log base 2 of 0 plus 2 plus 1. All right, I need you guys to help me out. What is log base 2 of 2? Whoops. Yeah, it is 1. Because again, you're asking, well, I should say, first person's right because 2 to the first is 2. So the answer is 1. But I think Alejandro is answering the bigger question, which is what's log base 2 of 2 plus 1, which is going to be 1 plus 1, which is 2. So yeah, this part's 1, and 1 plus 1 is 2. So my y-intercept is 2. And then let's see if we can find the x-intercept. Because again, right, we know that the logarithmic graph does this kind of deal. So it has to have an x-intercept. Let's actually find it before we try and graph it. So we're going to set the whole thing equal to 0. And so what I would do here is subtract 1. So log base 2 of x plus 2 equals -1. And then I would rewrite this as an exponential equation. So I'm going to rewrite this as 2, my base, to the -1 power equals x plus 2. And 2 to the -1 is 1/2. And then subtract 2. 1/2 minus 2 is x. 2 is really 4/2, so 1/2 minus 4/2 is x. So -3/2 is x. So it's going to be like right about there, I guess. And again, the graph does not have to be perfect. Looks like that. The domain we already found. The domain is everything bigger than -2, not including -2. The range for a logarithmic graph is always everything. It goes all the way down to -infinity, it goes all the way up to infinity. Okay. So it is 201. I understand if you need to go, you need to go. But I am going to do this last graphing question because I think you guys will want to see it. So let's look at this last one, which is x squared minus 4x plus 4 over x squared minus 2x plus 1. And I really do think it's in your interest for these rational functions especially to factor them if they're not factored. So I would also encourage you to see this as, oh, the top part is really x minus 2 times x minus 2, which is x minus 2 squared. The bottom part is x minus 1 times x minus 1, which is x plus 1 squared. It's going to make it easier to do stuff. So y-intercept, set x equal to 0, and f of 0, I would actually probably plug it into the unfactored form. If I plug in 0, I get 0 minus 0 plus 4 over 0 minus 0 plus 1. I get 4 over 1, which is just 4. For the x-intercept, we're setting the top equal to 0. And you could either square root both sides, or you could just say, well, the insides have to be 0. X minus 2 equals 0, x equals 2. For my vertical asymptote, we're setting the denominator equal to 0, which is going to be setting x plus 1 squared equal to 0. And we're going to get x equal to negative 1. And finally, for the horizontal asymptote, if we look back at the original unfactored form, we see that the degree on top and the degree on the bottom are the same. So the horizontal asymptote is going to be 1 over 1. Right, because that's a 1x squared over 1x squared. All right, that's everything. Let's graph it. So I've got a y-intercept of 4, an x-intercept of 2, a vertical asymptote of negative 1, and a horizontal asymptote of 1. And I'm going to start here. As I go to the right, I have to hit that point. And now, I know I have to bounce off this point for 2 reasons. One, I have to get closer to my horizontal asymptote. And if I go below, I can't go back above the x-axis because there's no other x-intercepts. Also, the x-intercept came from this factor, which has an even multiplicity, so it's definitely going to bounce. And then we just get closer to our horizontal asymptote. On the other side of this, to the left, I have to go up to infinity like this, because I can't go down because there's no x-intercept. And then on the other side, I have to look like this because, well, if I was down here, I would have to cross the x-axis to get close to my horizontal asymptote, which we can't do. Or you could plug in a point. If I plug in negative 2, well, in fact, you can see that this whole thing is always positive, because you got something squared over something squared, which is always positive. So if you plug in something like negative 2 minus 2 is negative 4, negative 4 squared is positive 16. And the bottom, negative 2 plus 1 is negative 1. Negative 1 squared is positive 1. So you get 16 over 1, which is 16. And that's the graph of that. Oh, domain and range we can answer here. The domain is everything except for negative 1. I definitely get all the x values except for negative 1. The range we can also answer, because I can see that the y values are never negative, and I do get 0, and I do get everything from 0 to infinity, right? I'm not missing any y values. I even get the y value of 1, because I do have to cross this horizontal asymptote. So the range here is 0 inclusive